Hello everybody. So what we're going to be looking at today is inverse trig 2, right? So part 2, I guess I should say. The first one was part 1, obviously, and this is part 2. So this is going to be a much easier section than the last one. So I don't think the last one was that hard once you learned how to use those little tables of values to calculate the inverse trig functions, but this one's easier. This is mostly just going to be like applications of, let's say, inverse trig. Mostly we're just going to be finding the sides of triangles. Let's see, yeah. Sides of triangles. And the angles in triangles. All right. So before we do like a real example, I guess, let's look at a triangle here. Now, there's a triangle. And so let's say I told you that this angle was, I don't know, that looks about 35 degrees to me. Okay, so we'll call that 35 degrees. And let's say that we knew that this side was, I don't know, 20. And let's say this side was x. And we want to find x, right? Suppose we want to find x. So to find the length of side x, you would write this. And you've done this before in an earlier section, so this is actually a review, right? What you would say is you would realize what sides of the triangle you had, right? If the angle's right here, then that means that this x side, that's the adjacent side. And the 20 here, that's the hypotenuse, hypotenuse. And so if it's the hypotenuse, we have the adjacent and the hypotenuse. We know adjacent and hypotenuse are related by this formula. What formula? The cosine of theta is the adjacent over the hypotenuse, right? And then from there, you can plug in your numbers, or actually, not necessarily numbers, but the sides. Plug in the sides in terms of variables and stuff. So plug in, what do we know? We know that the hypotenuse is 20, and we know that the adjacent side is x. So you put those in, and you get, oh, and also we know the theta was 35 degrees, right? So we know all this stuff right here. So we're just going to put it in for the theta and the adjacent and the hypotenuse. So we do that, we get cosine of 35 degrees is equal to adjacent, which is x, over hypotenuse, which is 20. Then you would multiply by 20 on both sides, and we would get x equals 20 cosine 35 degrees. From there, you just need to calculate it, right? So you use a calculator from calculator. So let's see if I can do this properly. Trying to learn thing. Oh, did it. Almost. There we go. So we need to calculate 20 times cosine 35 degrees. So we make sure we're in degree mode. So where's that? I don't see it anymore because everything's in a different place. Oh no. Was that actually gone? It can't be, right? Okay, we are in degree mode. It does disappear. All right, anyway, we're in degree mode. So I can type in 20 times the cosine of 35 in degree mode, hit enter, and we get a number. And the number is 16, oops. Did not write any of what I just wrote. Did erase what I just wrote, that's nice. 16.38. Okay, and that's our answer. That's going to be the length of the side. And so that's something that you already know how to do. That's not new. Okay. What's new is if we're missing the side of a triangle, how are we gonna? Sorry, if we're missing the angle of a triangle, how are we gonna find that? Okay, so let's consider a case. What if the angle on a triangle? That's where we need inverse trig. Okay, so let's look at an example. So an example of that would be, I'm just going to draw another triangle. See what we get. Right triangle, they have to have a right angle, so this is a right angle. Thanks, Note Program, really appreciate that. So let's say I call this angle alpha. I don't know alpha, but let's say I know that this side is 20, and let's say I know that this side is 6. Okay? And I want to find the angle alpha. I could have used a theta there. I don't know why I did. I'm going to say find the angle theta. Nope. Alpha in degrees. All right. So you kind of do this the same sort of, like you started out the same way that we started the previous problem. What you would say is you'd say, okay, well, what do we have? We have this side and we have this side. Well, what are those in terms of theta? So in terms of theta, nope, sorry. What are they in terms of sides of the triangle? This side is the hypotenuse, right? And then this side over here, this side is the opposite side. So we have the opposite and the hypotenuse. So since we have opposite and hypotenuse, we'll use a sine. So we'll write sine alpha is equal to, well, we know it's opposite over hypotenuse, right? That's what we're going to use. And we're going to put in our stuff. I already put in the angle. I called it alpha. Don't know why. So the opposite side is 6, and the hypotenuse is 20, right? And you're trying to find alpha. So to find alpha, you're going to take sine inverse of both sides, right? That's going to be the key to doing this, is taking the sine inverse of both sides. So you apply a sine inverse on the left and you apply a sine inverse on the right. So we're applying it to sine alpha and we're applying it to 6 over 20. Now the point is, when you do sine inverse of sine alpha, they cancel out, right? Because they're inverses of each other. So inverse functions cancel here. So you're just left with alpha. And then you have sine inverse 6 over 20, and that you're going to use a calculator for. So let's try to do that. So hopefully we're still in degree mode here, since I can't see. But you're going to do this the same way that we did it before. So a sine inverse, remember usually you have to hit second. On my calculator here it's shift, sine inverse, and then just 6 over 20, close parentheses, enter. And it tells me the answer. and I'm in degree mode, so my answer is in degrees. So like if I say 46 degrees. So now just make sure you understand that the mode does matter, because up here I can see I'm in degree mode. I don't know if you guys can read that. It says there's a little tiny DEG on the top there. I don't know if I can adjust it. Whoa, no. I don't see it. Oh, there it is. Yeah, I'm in degree mode. So if I change it to radian mode, right? If I change it to radian mode and I do that exact same calculation, so hit enter again, now I get 0.3, right? So I get a different answer. So if you want degrees, you need to be in degree mode. So I do want degrees. Oh no, I don't want to upgrade them. I don't got any money. So degree mode. Oops. Up. Degree mode, get degrees. That's what it comes down to. And there you go, that's it. So really, you're just going to be doing a lot of stuff like this, I think, on the homework. We'll see. But that's what it should be. So here's the first real example from the homework. So one thing I will say is that they like to, they're liking to mix up like what you have to do. So you have to do like multiple things to solve one problem. So like they've got a triangle, they've labeled the angles A, B, and C here, and we know two sides. No, we know one side, and we don't know the other side. So this is what we've got, and what they want, we need to find the following here. So I'll leave space for it. Come on. My life is so hard. Just make a square. Thank you. We need to find the little a. Oh, you're really getting on my nerves now. We need to find the little a. We need to find the little b. And we need to find the big B. Those are what we need to find. So the little ones are the sides. So like this is a side. This is a side. And this is an angle. Right? So the uppercase letters they're using for angles. All right. So let's just think about what we can do. So we've got an angle and we've got an angle and we've got a side. Now, first of all, there's an angle right here, right? This is the angle B. There's more than one way to get that angle. So one way to get that angle is just to use the fact that angles add up to 180 degrees in a triangle. So we know that like the angles A plus B plus C have to be 180. So if you plug in what you know, we know that the angle A is 18 degrees because we can see it. The angle B, we don't know what it is. The angle C is 90 degrees because they labeled it as a right angle, and that's all 180. So if you want B, you just take 180 and then subtract 90, subtract 18, and then that'll be it. So if I'm not going to use the on-screen calculator because it's slow. 180 minus 90 minus 18, you're going to find that B is 72 degrees. So I would just do it that way. We don't need any kind of advanced math to find that. Okay, so now we got the angles. At that point, you need to find the A and the B, right? So my advice to you is say, well, if we're looking at, like, pick an angle. Now, one thing I'll say is we have the angle 18. That was given. I have the angle B now. I know what it is, right? The angle B is 72. But if I can avoid using that 72, I will, because I would rather base my calculations on the given information, which I know is correct, rather than my own information, which could be incorrect if I made a mistake, right? So like if I have a choice between using the 18 and the 72, I'll use the 18 because it's always possible that I calculated the 72 incorrectly. Now, so for the sides here, let's see, sides. What we're going to do is you're going to need to take a known angle, a known side, and the side that you are trying to find, and write a trig function. Now the reason I'm writing that out is because you get to the point where there's so many numbers and letters and stuff on your picture that you might not be sure about what to do next. So we need to use stuff that we know. So we know the 18, so I'm going to use the 18. We also know the 15, so I'm going to use the 15. Now which side am I going to try to find, the A or the B? Let's just find the B first, right there. Okay? So I'll use those three. Now, if you think about it, in terms of this angle, right? If this is the angle theta, I know it's A, but if that's the angle theta, then what are sides B and 15 in terms of theta, right? In terms of opposite, adjacent, and hypotenuse. So for theta, or for A, this is the hypotenuse. And for A, this is the adjacent side. Now it's important that you think of it that way because if you're talking about the angle, oh come on. If you're talking about an angle right here, right, this one, then way over here is the opposite side, right? The A is the opposite side. But if you were talking about, really, if you were talking about the angle over here, right, the B, then this would be the opposite side. So it all depends on what angle you're talking about before you can talk about which side is the adjacent and which side is the opposite. You just got to know what side you are trying to mention. So for us, with the B, the 18, and the 15, I have a theta, an adjacent, and a hypotenuse. So adjacent and hypotenuse suggests that I should use a cosine. So I know that in general, cosine theta is adjacent over hypotenuse. So for us, we're finding, what are we finding? The B? Find B. So the angle, what's the angle that we're using? A, which is 18 degrees, equals the adjacent side. The adjacent side is B over the hypotenuse, and the hypotenuse is 15. So B is simply 15 cosine 18, and make sure you are in degree mode. How did that not line up? Weird. B equals. So that's where you're going to use a calculator again. I'll just leave this up. So we're doing 15 cosine 18, and I can just double check that I'm in degree mode. I am. Clear. So we need 15 times cosine 18. Enter. 14.2. I'll just say 14.3. All right. Easy. Now the other thing is we need to find A. Well, we can use all the same information, right? What we can do is we can say, well, A is the if we're using A equals 18, then the little a is the opposite side. So we could use simply sine 18 degrees is, well, sine theta is opposite over hypotenuse. And then for us, sine 18 degrees is opposite side is A, hypotenuse is still 15. So A is 15 sine 18. So you go to a calculator again. 15 times sine 18. Enter. .6. I'm only going one decimal point there. All right. So what do we got? Well, we got A is 4.6. And B was, I don't know, I already forgot it. B is 14.3. Could have sworn I put a box around that. Do you remember that? Okay. Must have deleted it. All right. So we found all the stuff. And notice we didn't even need, I didn't even use an inverse trig function to do that. Okay? It was unnecessary for this problem. But depending on the given information, we may need to use it. Let's see here. Okay, that's identical. We'll see if there's something else. Strange. Oh, okay, yeah, here. So here's one where you definitely need the inverse here. So, example. They go theta, 10, 5. And the question is, find theta in radians. They say round to 4 decimal places. That's a lot. All right. So again, all you have to do is identify the sides of the triangle. So if based on where theta is, this is the opposite side. No, it isn't. That's a lie. Based on where theta is, this is the adjacent side, right? It's right next to the theta. And this is the opposite side. 10. So we're looking at opposite and adjacent. So I know that the formula that relates opposite and adjacent is tangent theta is opposite over adjacent. All right. So then you put in your numbers. So I have tangent theta, we don't know tangent theta, is opposite, which is 10, over adjacent, which is 5. All right? So that's 2, actually. But then, remember what we're going to do, you need an inverse trig function to find it. So if tangent theta is 2, that tells you that theta is tangent inverse of 2. Right? And I didn't write I didn't write it. I could have. I guess I'm about to. But the idea is you do tan inverse there, and then you do tan inverse there. So tan inverse of both sides. But people don't write that because they know that how it's going to work. All right, 4 decimal places they say. Let's leave some space, and let's try it. So we need a couple of things. Number 1, we need to make sure we are in radian mode because they said radian. So come over here, switch to radians, switch back, let's clear this out. And we need tangent inverse of 2. So shift tangent inverse 2. Enter. So we want, and this is in radians, 1.1071. Just typing it in, hitting submit. All right, good. No surprises in what they want for an answer. Let's do another one for practice. So they put the theta up here, 9, 5. And again, we're finding theta for decimal places. So let's abbreviate. Sentence hard, 4 decimal places. All right, how do we do this? Again, hard part is identifying the side of the triangle, right? Is that the hard part? There isn't the hard part. All right, so based on where theta is, this is the opposite side. Next to the theta is the 5, and the 9 is the hypotenuse. If you get confused, remember that the hypotenuse is always the longest side. Okay, always the longest side. Also, it's always opposite of the right angle. Okay, so that's my triangle. I've labeled what it is. So we have a 5 and a 9. So the 5 and the 9, adjacent and hypotenuse. So the trig functions we want are cosine theta is adjacent over hypotenuse. So for us, cosine theta is adjacent, which is 5, over hypotenuse, which is 9. Kind of like that, being able to move stuff around. So if you take the cosine inverse of both sides, again, you don't generally write that, but I am for practice now. Cosine inverse of cosine is theta, and on the other side you have cosine inverse of 5 over 9. I didn't say it, but radians. We should be in radian mode. So what do? We have cosine inverse, so shift cosine inverse 5 over 9, parentheses, enter. 0.9818. Easy. Certainly that is correct. All right. Just looking for a different type of problem. Oh, very sneaky. No, not really. They say find theta in degrees. Round to nearest tenth. All right. So again, there's nothing really special here. This is just going to be the same thing. The only difference that we're going to have here is that they are specifying that we answer in degrees. All right, so there's my triangle. So our answer is in degrees. So let's figure out what sides we have. So long side is a hypotenuse, which we don't need for this problem, but that's still where it is. So the 4 must be the opposite side, opposite of the theta, and so the 5 is the adjacent side there. So we have the adjacent side and the opposite side and the theta. So what trig function relates adjacent and opposite? It's the tangent. So we write tangent theta is opposite over adjacent, actually. So tangent theta, which we don't know, is opposite over adjacent, 4 over 5. Like that. I left space because, well, actually I don't want to leave space. I left space to write on it, but I don't like doing that because then it's hard to tell what it looked like before you did that. All right, so you go sine inverse. Why would you do that? Don't do that. You go tan inverse, because it's a tangent. Tan inverse 4 over 5. Of course, on the left, tan inverse of tan is 0, not 0, theta. And on the right, tan inverse of 4 over 5. What's the difference between last time? Degree mode, right? So we switch over here, switch into degree mode. Clear, clear, clear. We need simply tangent inverse of 4 over 5. It is 38.7 degrees. Because we have to round to the nearest tenth, so the 6 goes up to a 7. And that's it. All right. Let's click through a couple more of these. Feel like there should be some word problems. We'll do one of those in a second. Oh, okay, there we go. Yeah, I like that one. I just want to make sure we do all of the problem types. So I've got a triangle, ABC. They tell me that this is a right angle. They do not tell me the A or the B. What they do tell me is this is 5, this is 11, and then this is the square root of 146. Okay? And what they want are A and B. So we have to find A and B. In what kind of... They don't even say. So they forgot to say, but I'm going to assume that they want degrees. And the reason I'm assuming that, even though they don't say that, is because they said round to 1 decimal place. And as you've seen, when they ask for radians, they want several decimal places. And when they ask for degrees, they only want 1. Because when you have 1, you still get like 3 significant figures there. So I'm going to assume they want degrees. They didn't say that. All right, how are we going to do it? So first of all, let's just pick one, pick which angle we're solving for. Pick an angle to solve for. All right, so we're looking for A and for B. We might as well do A. Let's do A. All right, so if A is our angle, right, so we're doing this angle, so that's my theta. For the moment, that's my theta. Then in terms of that theta, what are the sides that we have? This one would be the adjacent at that point. This one would be the opposite. And this one would be the hypotenuse, right? Now, we have opposite, adjacent, and hypotenuse. So we could use any of the trig functions we want. You can use a sine, or a cosine, or a tangent. All of them are fine. All you should do is just pick, which one you want. I think I'm going to use a tangent. The reason I'm going to use a tangent is because I notice that it's going to be easier to type in 5 and 11 into a calculator than square root 146. So I'm just being lazy. So for us, we have tangent A is opposite, which is 11, over adjacent, which is 5. I'm going to skip the next step. So A is going to be tangent inverse 11 over 5. Right? That's all you got to write. Do it on the calculator. We want degree mode. So clear this. We are in degree mode, right? Yeah. So we simply want tangent inverse 11 over 5, close parentheses, enter. So we want 1 decimal point, they said. So 65.6. Okay. Come on. Go. Go away. Go away. Hold on. I'm trying to figure out. Okay. The calculator was not on your screen, but it was still on my screen and wouldn't go away. All right. So we have this in degrees. Now, you have 2 choices to find b. So to find b, one method is, a plus b plus c has to be 180, right? Because you can just plug in the numbers now that you know. So like, wait, yeah, okay, we can do that. So a was 65.6. B we don't know. C is 90. So B is 180 minus 90 minus 65.6. Again, I'm going to use my hand calculator here because it's faster for this. So you get B is 24.4 degrees. So that's one way to do it. If you want to, though, you could solve for it the same way we came up with the B. Or sorry, the same method we used for A. No, that was angle A. What? Yeah, okay, that was right. We could use the same method as we used for angle A. So you'd have to come back up here and say, well, all right, if we were finding angle B, I'm going to do this in a different color. If we were doing angle B, then this would be my angle theta. And the 5 would actually be the opposite side. And the 11 would be the adjacent. So it all depends on which angle you're calling theta. So I could still use the tangent. I could say tangent theta is opposite over adjacent. And so tangent, it was B, is the opposite side. Opposite side now is 5. Adjacent side is 11. And so B is going to be the tangent inverse of 5 over 11. So we do that on a calculator. It should give me the answer I already know, though, right? The only thing that could be different is how it kind of gets rounded. So clear this out. Tangent inverse, 5 over 11, close parentheses, and 24.4 degrees. And there you go. So it doesn't matter how you do it, you're going to get the same answer because that's the answer. All right, and it would have come up the same if you had used, instead of using tangent, you used a sine, you used a cosine. No matter what, it was going to come up with the same answer because that's just what the answer is. Oh, okay. So there is another type of problem in here. So let's look at it. So like non-triangle problems, we're going to look at simplifying inverse trig expressions. Okay, so what are we talking about? We're talking about things like this. Like we mean like sine of cosine inverse of 1/2, or cosine inverse of sine of pi over 3, or something like that, etc. All right, and there's kind of cases like whether or not this is going to be easy or hard. Depends on the specific cases that you're talking about. So like, I'll look at an example and we'll use this to try to explain what's going on. So they say find cosine inverse of sine of f, where f equals 945 degrees. Okay, now in this type of problem, what you can do is this. This would be my advice. So you have the outside, no, come on. You have the outside function is inverse. So the inverse is on the outside. And then on the inside, you have a regular trig. All right. In this case, I would just evaluate this from the inside out. I would write cosine inverse sine 945 degrees and evaluate it from the inside out. What's that mean? Well, what I mean is I would just say we've got sine 945, right? I can find sine 945 on a calculator. I could even type that whole thing in. Right? I can make sure I'm in degree mode, because they say degree mode. And I could type in, just do it from the outside, inside out. So I could just do sine 945, enter, and then I need the cosine inverse of that, so I could go shift cosine inverse. Uh-oh, it's gone. So I guess, oh, I think result, I think that'll do it. That was weird. Let me redo this. So like you could type the whole thing in, like cosine inverse sine 945. Now the problem with using a calculator for this is if I type this, I'm going to get 135, which is the right answer. But if I do it in 2 steps where I go sine 945, enter, and I get like a decimal like this, and then you write it and you round it like -707, like let's say you stop there. Well, if you do that and then you try to work backwards and you go shift cosine inverse and you only type in -0.707, I just lost a lot of precision, right? In the decimal, I cut off a bunch of numbers. So when I do this, it's not going to give me 135. It's going to give me something kind of close to 135. See? And so if I answered 134.99, I'm wrong. That's not the answer. Okay? So if you're going to use a calculator, you have to be careful not to lose the numbers that way. And so the easiest way to do it would be to use a calculator that lets you type in the whole thing like that and then get an answer. Okay? Now, I bet that this is not the method that the book suggests that you do. Okay? What the book will probably do is this. So another method using the unit circle. Which is going to be significantly harder to do, but we can do it. So we can find 945 degrees on the unit circle. So I need a unit circle. Okay, so there's a unit circle. Now 945, like where is 945? Well, that's where you have to like find the equivalent angle. So like the reference angle. So like subtract 360, 945 minus 360, you get 585. I still don't know where 585 is, so 585 minus 360. So I get 225, and then I say, okay, where's 225? Well, 225 is 180 plus 180 plus 45. So actually, where that is it's a 45-degree angle in this quadrant, because this is 180, and so this is 225, because this is 45. Okay, so that's the angle. That's where 945 is. It's in the same place as here. Now, what are the coordinates here? The coordinates at that point are negative square root 2 over 2, negative square root 2 over 2. All right, from knowing the unit circle. So all of that, now I can try to do this. So what you would say is well, we've got please stop doing that. We've got cosine inverse of sine. It was sine, right? Cosine inverse of sine. Yeah, cosine inverse sine 945. Well, I just found out that that's cosine inverse of, well, what's the sine of 945? The sine is the y value. So it's negative square root 2 over 2. And then I have cosine inverse of square root 2 over 2. Now, in order to find that, you're actually going to need like those tables that we had from the other section. So cosine inverse negative square root 2 over 2. So I'm going to go to my other notes. They're not opening. Getting real tired of this program. So if I go here and I look for cosine inverse of, it was negative root 2 over 2. Here's negative root 2 over 2. And so the answer is 3 pi over 4. 3 pi over 4. Where, oh, it just deleted everything I just wrote. That's just fantastic. Awesome. Just really love it when it does that. So negative root 2 over 2, negative root 2 over 2. That's 225, which is the same as 945. So cosine inverse of sine 945 is cosine inverse of negative square root 2 over 2, because we found the sine of 945, and then I did the cosine inverse of negative square root 2 over 2, and we got 3 pi over 4 from my knowing how to do inverses. And that's not in degrees though, that's in radians. In degrees, it's 135. And you can calculate that, right? 3 pi over 4 times 180 degrees over pi radians. Punch that into a calculator. It better be 135, but I'm not even going to check. Okay? Now, that's kind of tedious, but that's probably what they're going to check. They're going to suggest that you do if you read the homework. But yeah. All right. Now, I do want to do another one of these real quick here. So they want sine inverse sine C, where C is 1230. All right. Okay. Now, we've talked about a lot about how you can just cancel these, right? Well, guess what? That was a lie. You can't do that. you can't just cancel sine inverse with sine, because the range of sine inverse always gives an answer in negative pi over 2 to positive pi over 2. Or if you want to do it in degrees, that's negative 90 degrees to positive 90 degrees, always. So the answer could not possibly be 1230. Right? It can't be 1230 because that's not in between negative 90 and 90. I said and, but negative 90 to 90. Okay? So it's just not a valid answer. So you can't just cancel. Right? You can cancel on triangles because triangles don't have that issue. All right. So let us do it. So how are we going to do it instead? Well, we're just going to do it like it was the same as the previous problem here. So you have sine inverse of sine of 1230 degrees. And again, I'm going to advocate that you just punch it into a calculator that can handle it. Right? If we're in, what are we in? Degree mode, I should just be able to go sine inverse sine 1230, and the answer is not going to be 1230. It's going to be something in between negative 90 and 90. And so it's simply 30 degrees. Now, if you do want to work it out by hand, remember the other way to do it, you would have to say, well, 1230, where is it on the unit circle? Lopsided, don't care. Right, so you'd have to do 1230. We're going to have to subtract 360. 1230 minus 360, you get 870. So minus 360 again. So I get 510. So I subtract 360 again. So I get, oops. So I get 150. And I do know where 150 is. 150 is about here. Right? And so I look at my unit circle, I get the coordinates, negative square root 3 over 2, comma 1/2, right? I'm assuming you have a unit circle to look at. Print one out if you don't have it. So then I can do this because I have sine inverse sine 1230 is sine inverse of, well, what's the sine of 1230? The sine of 1230 is going to be 1/2. And then I'm going to go look up sine inverse of 1/2 in my other set of notes. So here's my other set of notes. Sine inverse of 1/2. So 1/2 is here, pi over 6 is here. So the answer is pi over 6. But that is in degrees. It's 30 degrees. Okay. All right. Now you can do the same exact thing in Radian mode. So another example, find sine inverse cosine n, where n is 5 pi over 2. So 5 pi over 2, you could do it by hand. 5 pi over 2 is actually all the way around. Oops. All the way around and back here. That's 5 pi over 2. So you've got 0, 1. So that sine inverse of the cosine there is 0. Then you go look this up in the other notes. Good. No, look up. Why did I write good? So look that up in the other notes. And sine inverse of 0 is 0. All right. Or could have definitely come here, switch into Radian mode, important, and we could have done sine inverse of cosine of 5 times pi over 2, close. Enter. 0. All right. Let's see. There's another one. Another one. Another one. All right. So you have a bunch of these. Just make sure you're in degree mode if you use a calculator, and if you do it on the unit circle, I don't know, no advice. But that's what it is. So I'm done with this now. I will upload this, and I will talk to you guys later. See you then.